Tron, are you hearing me? Tron, your voice is off.
Hello, I hear you.
Okay. So you want me to operate this slide for you?
Oh, I can do it I can do that from my computer, from the computer here.
Okay, so I don't have to.
So you don't have to
touch
open this. Yeah.
Oh, okay.
Hmm.
And the audience can look at this slide and the computer screen there, right? Okay. Anyway, I'm not touching this.
Okay.
Mhm.
Yeah. It's time. I think we wait for 2 more minutes and we start.
Okay.
Okay. Welcome everyone to the room. This is the workshop Seagrass Mapper. My colleague Genki Terauchi will be the main presenter for this workshop. I'm just his helper, so I'm his avatar, but he will be the main presenter. Now, I guess most of you through the workshop, through the conference, has been exposed to seagrass mapping by satellite image and by remote sensing in general. And I think it's good. It's a good chance for us to introduce more details what we do and introduce a platform or tool that non-remote sensing experts can try out how this remote sensing process works and try with your own training data to see what remote sensing can achieve in terms of mapping from your area. So I guess I will be passing the presentation to Genki. It's now 2:30. It's now 3 a.m. in Japan, but he's presenting on Zoom. So good morning, Genki.
Hi, good morning and good afternoon, everyone. My name is Genki Terauchi. I'm working for Northwest Pacific Regional Environment Cooperation Center. We call ourselves NPEC. It's a non-profit organization working with United Nations Environment Program. I will be introducing our program later, but today my talk is focused on our cloud-based mapping tools for Seagrass, Seagrass Mapper.
Could you zoom in a little bit? It's a bit small on the slides. So
okay.
maybe make it like 200%.
Okay.
Yes, 200 would be good.
Yeah, something like this, 150. Okay, so I think you have handout distributed advance, and I will go along with this timetable. So now it's Tron to introduce what is Google Earth Engine and its potential for mapping Seagrass. Can you take over, Tron, for a little bit?
Okay. You want to introduce the whole timeline? Just people have a
okay. So yeah. So first, Tron will introduce what is Google Earth Engine, and then I will be demonstrating Seagrass Mapper using the case study in my field, Nanao Bay. And then we will let you to play with Seagrass Mapper using the exact same field data and to test different parameters and how you end up the different classification result. And then we will be I will be demonstrating how to upload training dataset into Seagrass Mapper. And then the second hands-on exercise will be scheduled to play with Seagrass Trainer. This is another tool to talk to Seagrass Mapper. And then we will be wrapping up the whole session with question and answer. Yeah.
Okay.
And I assume that everyone has Google Chrome installed in your laptop, because this is necessary in the entire session. Yeah. That's all.
Okay. If you haven't signed up, you can sign up now. It won't take too long. For Earth Engine, it will take about 2 minutes. For Seagrass Mapper, I think it's also about just a few minutes. So anytime you can sign up. If you have any questions, just raise your hand. While Genki is speaking, I can go to your computer and see if I can help you with your problem. So now I'll go with the first part of the introducing Earth Engine and its potential for mapping seagrass. Slideshow. So as it has been established, we need a platform for collaboration. On the remote sensing side, we can process a large amount of data. We can easily do country-wide mapping. We can do time series of 30 years. We can go back in the past and see how seagrass has been changing until now. And we can do that repeatedly, and it's cost effective, it's cheap, but the resolution is coarse. We don't see that much. We don't see that well, and we need a lot of time ground measurement for validation. And another theme that has been discussed is that the uncertainty has been very well communicated. While the field scientists have more detailed observation, more measurements, more quantities that they could look into, more characteristics, and the results are most of the time seen as more reliable as truth, because they've seen it, they're in the place. So those are the advantages, but there are cons. So it's costly, it's usually difficult to scale, and then you cannot go back to the past. Suppose if you could not be there for certain events, it's impossible to go back again. So we have different pros and cons, and it's a good need for us to collaborate in many ways. And then therefore we need a platform to collaborate. So a platform should be able to map seagrass reliably, and so it should give somewhat usable result, not only for the researchers but also for managers. It's also should be easy to use for non-experts, especially when you want to, because it's a collaboration, you cannot use a tool that you have no idea how it works, and it really makes it difficult to communicate between the field and the remote sensing scientists. So it should be somewhat easy to use, preferably with some graphic user interface, and it should be easy to share between the developers and the user. It should be easy to shoot back and forth how to make it better. So Google Earth Engine has a few things that answers those needs. It's an advanced tools for remote sensing. It has high computing powers. Most of the machine learning, deep learning algorithms are available, as well as the more conventional methods, as well as it has the ability to make graphic user interface and application dedicated for specific needs, such as the one we're introducing today is an application developed on the platform of Google Earth Engine. That is going to be the Seagrass Mapper. And because it's cloud-based for storing its data and processing, you actually don't need a powerful computer. It could be a school computer. It could be any laptop, as long as it can access the browser. So this is really useful for when you want to work rapidly in the field, or even just with your iPads or iPhone. I've tried with my iPad just to do this processing, because everything is in the cloud as well. It will be easy to share the result as well as the data. So I can easily share to you the entire thesis of my doctor, if you want, of how I mapped the Earth and seagrass in Vietnam for the 30 years as I represented. You can see everything on your computer. So how it works is that, so all the satellite images that are publicly available, such as the Landsat, the Sentinel-2, will be stored in Google's server. and the user would request the server to do computation using its platform. So usually through programming language such as JavaScript or Python, or in this case, the graphic user interface. And these applications built on the platform can provide the specific needs so that you can use it. So we will be introducing the an application for it is Seagrass Mapper. So there's no downloading involved. But if you want to have your own imagery, you can also upload it to Earth Engine and do the same processing as long as they have the image on their server. So that's it from me. Is there any question from this part? Otherwise, we go to Seagrass Mapper. Cool. One question? Yes. You can also upload your training data. You can also upload your bathymetry data, everything. As long as it's in a compatible format. You don't want to upload in a different projection. Yeah. But everything will be standardized for you. So cool. All right. So we go back to you, Genki.
Okay. Thanks, Tron, for introducing Google Earth Engine. And okay, you see my slide?
Yes.
Okay. So I will first introduce a case study of mapping seagrass in Nanao Bay using Seagrass Mapper and the Seagrass Trainer. Okay. I work for this one of the regional C program of UNEP, and our program is located in the Northwest Pacific. There are four countries involved in this program. We work with Chinese, we work with Koreans and Russians and Japanese scientists. The program was adopted in 1994, and these are the geographical coverage of the program. And there are 17 other regions across the world today, and so I think the participants of the workshop here are familiar with your own regional C program. So please, go check what kind of Seagrass mapping programs are available in your region too. Okay, so we work with a lot of remote sensing data from the last 2 decades, and we have mainly 2 themes about our remote sensing applications. We've been working with eutrophication assessment for a long time, but from 5 years ago, we decided to apply these remote sensing techniques to mapping seagrass, and developed these 2 applications on the web. One is Seagrass Mapper, and another one is Seagrass Trainer. We will be working on both tools, but Seagrass Mapper is the application that gives you a classification result of the seafloor. So this is, I mean, both tools are important, but we will be spending more time on this tool. Okay, so if you type mapseagrass.org, you will see a website like this, and there is apps and maps section, and both Seagrass Mapper and Seagrass Trainer are accessible from this. Of course, you can Google search these words, and then the result will take you to the website. Okay. Okay. So this is roles of Seagrass Trainer and Seagrass Mapper, and we use Seagrass Trainer mostly for registering training data for Seagrass Mapper. And Seagrass Mapper will use those registered data as classifier, in other words, training data to map seagrass using satellite imagery. So we will be working with both tools. And I will be explaining the difference between these two in details in the second part of my presentation. Because all Google tools are banned in China, we had to develop some solutions for Chinese colleagues, and then Seagrass Trainer was the answer for that. This tool can do a mapping, but not on interactive basis. This tool will send email to Seagrass mapper and reply the classification results. There is a time lag. And in the United States, in Japan, it's better to use Seagrass mapper. This is fast, and you can see the result interacting. Okay, now I will go to my field. This is location of Nanao Bay. I live in the middle part of this Noto Peninsula, and you see this little island located in the small bay, and the western section of the bay is rich Zostera marina habitat, and there are many other spots that seagrass habitats, but we will be introducing this Nanao Bay here, located in the center of the peninsula. So, and in this bay, there has been a large-scale die-off of Zostera marina reported, and the local scientist claims this is due to higher sea surface temperature in summer. And this is a comparison of 2012 to 2014. And only 2012, the summer temperature exceeded 30 degrees Celsius, and there has been a massive die-off reported. So to look at this phenomena using Seagrass mapper, I did a comparison of 2014 and 2019. And then I used Landsat 8, OLI sensor, and Sentinel-2 MSI sensor. For field data, there are two field sampling conducted in June and October in each year. And for image corrections, I used atmospheric correction by deep water method and water column correction by bottom reflectors index method. Description about the explanation about these algorithms are explained in Seagrass mapper and Seagrass trainer manuals. But if you want to know more details, you have to read the papers. For classification, I used supervised classification by random forest method. 70% of the field data was used for training, and the remaining 30% was used for validation. So these are the images how we get the seafloor informations. These blue trucks come from ship trucks, and there are more than 100 stations that we deployed underwater video cameras. And there are 5 channels of the camera comes with attached to this small unit. The one goes down looking the seafloor, and the other one other 4 cameras looking at horizontal directions. So looking at images through these 5 channels, we decide the seagrass coverage of the floor, and classify the sea floors informations. And for these green tracks are so shallow so that it's not accessible by a small fisherman boat. So I often use a stand-up paddle surfboard to do a little investigation on the seafloor with a very handy GPS device and digital still camera. So and these days I've been using iPhones and trying to mount these iPhones underneath of the standard paddle surfboard. And I am also a developer of a surfboard. So if you are interested in like mounting your gears, please contact me. I have my workshop in my house. Okay. So in another way, I decided to allocate 5 different classes for seaflowers. This one is sparse seagrass, and this one is sandy bottom. As you see, sargassum here, seagrass with sargassum, and then seagrass. It worked very well for image taking on the same day by Landsat, June 1st, 2015, but it didn't work quite well for another date. So I will be explaining a little bit from now on. Okay, so from the field sampling conducted in June, these are the first training data set I prepared. I think back then I was using MB software to draw this training data set. And these are the number of pixels for 5 different classes. And here 1 pixel is 30 by 30 meter resolutions. And as I said, 70% was used for training data for classification, and remaining 30 was used for validating the result. Okay. And I created a similar data set for other seasons based on the field sampling of the month. And after you have this data set, you are ready to do a classification in Seagrass mapper. So these green patches here are seagrass beds, and then there are some seagrass remaining even in December. Remember, there's little time difference between the field data sampling period and the satellite image date. This is because there are there are not images available in October in case of 2015. So I had to look for image that is close enough to do the classification, and that was available in December 8th. And for year 2019, there were another seagrass beds distributed in entire bay, but most of them disappeared in September time, and you see only little patches remaining here. So you see the difference between this 2015 and 2000. Oh, sorry, this is the image below is 2019. This is my mistake. I will correct it. Okay. And this number here is overall accuracy. And as you can see, only this day, the accuracy is very, very low. And this is due to a very limited data for class 3. So I had to somehow correct the training data set, maybe merging or deleting the class 3 so that I can achieve better overall accuracy. So I'm just telling that I just need further adjustment to estimate seafloor with better accuracy. Okay, Seagrass Mapper has an option to do the validation. So you see, this is a confusion, what's called confusion matrix. It gives you how well your training data sets reflecting the real world, and also the other way around. So you can validate the result at the location of the sampling data. And you can also calculate the number of the area extent of associated with the class. And here is a chart. And you can also download this as a CSV, and also you can download the entire map, the GeoTIFF data format. So if you could, the numbers of the area extent are given in the unit of hectare. So if I assume the class 1 and class 5, the seagrass area, it's going to be 950 hectare. Okay. Okay, so back to the our scientific part. So there are more seagrass died in 2019, and this is a report coming from local official institute saying the sea surface temperature of the 2019 was higher, and it exceeded 30 degrees Celsius. And it was lower than 30 degrees Celsius in 2015. So it was consistent, and it matches with a claim of the local scientists saying more seagrass dies because of higher sea surface temperature. I also analyzed sea surface temperature images taken by remotely sensed data by 2 different sensors, and both sensors showed higher temperature in summertime in 2019. These are the summary, and I still need to work on the field data set, especially for the images of July 2019. But overall, I was able to detect massive seagrass die of 2019, and also I was able to illustrate the seafloor information using Seagrass mapper. About the algorithms used in this classification and this demonstration, there are more information available on the web. We are updating this manual right now, but you can read the most updated version on the web. So if you're interested, please read these manuals available on the web. Okay, so now it's a hands-on time, and I assume you have access to Seagrass mapper. So when you open Seagrass mapper,
Genki, do you want to take questions before that?
Oh, yeah. Okay. So
if you have any questions, please just show Genki that he can see everyone. Is there any question? Yeah, go on. He won't hear you.
Hello. Yeah, my question would be whether training data has to come in pixel form, or can it be like point features, or do they have to be raster features?
It can be both.
Excellent, thanks.
And if you look at this appendix, there are more details information about how Seagrass mapper look at field data. Okay.
Thank you. This looks like a really fantastic tool for people that don't necessarily want to deal with the nitty-gritty of learning machine learning and code-based approaches and just want accurate outputs. I guess the broad question is this, I see that you're recording this presentation. Can I get a copy of the presentation to pass to local managers down in Australia? Because this is exactly what some of my collaborators are looking for in terms of a tool. And yes. If possible, I'd like to potentially put you in touch with some of them, because this is honestly, this is a gold mine for what they're looking for.
Yes, of course, you can share the screen. I mean, share the slide of this presentation. It's available through the Handout. I'm not changing the links, so please do, and please let me be in touch with your professor.
Yeah, awesome. Thank you.
Genki, can you also quickly show the website? Because I believe the entire tool and training is available on the website. So could you show quickly the publicly available website to show the tool?
Well, yeah, you just need to type map Seagrass.
Yeah, not everyone had their computer here, so.
Okay. So, yeah, these are the portal, the main entrance of everything we develop. So if you click apps and maps here, or you just need to scroll your mouse, and then there is a pull down, gives you a link. I mean, take you to Seagrass Mapper.
Yeah, but I want to add to that point, because as you said, it's a really valuable tool to communicate between remote sensing scientists and the manager, but it's not supposed to be a shortcut for managers to skip through all the remote sensing, because if they treat it like a black box that they just put in the training data and somehow get the Seagrass area map, it could be misleading. So this is intended to be more transparent, but not to remove the remote sensing specialist from the conversation. Yeah.
They're currently attempting to do all of their work in QGIS, but I would like them to have access to different algorithms and more explicit control. So this seems like a perfect medium point between
Yes.
doing stuff with like clicking the only geographical stuff or doing it in R or Google Earth and Python coding.
I see.
Yeah.
And for the questions before, did the training data have to come in pixel form or points? So we provide points as training data, but you need to consider the resolution, because 1 point representing a 30-meter by 30-meter area is a very rough estimation. So that question is an important question that needs to be discussed on how you use the training data and what it may imply. But yeah, it's a good point. Okay, yeah, I think if we have no more questions, we go to the hands-on of the Seagrass mapper. All right, that's probably good.
Okay, so
and is the what is square here to show
this is the
hide self view. You show me, but I don't remember.
okay.
But it's not that important.
So this is a screen of Seagrass Mapper at the beginning, and then here I want you to type in the asset folder name. Here is the window that Seagrass Mapper know the your sample dataset, and in this case we will be using. Oh, hold on. Yeah, this magic keyword here, sample _ nanao _ 1506. So if you just copy this one and paste that information here and click load asset, this will direct you to the location of your area of interest. And in this case, this is my area of interest, and Seagrass Mapper will take you to the location. Okay, so is everyone with me? Tron, I think you can help me if everyone is looking at the same screen. Okay, so I will just go
Genki?
proceed. Yes?
Is there a way to zoom in on the interface a little bit? Does it? There's oh yeah. Yeah. That's very helpful.
Okay. So you need to type yes, you need to copy these letters available in the handout and paste it and click load asset. And this contains training dataset coming from the field survey of June 2015. So that's the indication of the name here. Okay, can I go proceed? Strong.
You can.
Okay, so once you load asset, the next thing you do is to search for satellite images matches the field sampling period. And in this particular case, I will change to Landsat 8 as sensor. And I just look for images after June 1st of 2015. So I just changed the sensor name and this period here. And then I click search button. Seagrass mapper will give you list of images matches this criteria. Landsat 8 Tier 1 TOA reflectance data available from June 1st, 2015. And I will just use the very first one comes in the list. You can just choose what other images will look like. And it's better that there are no time difference between the field data and satellite images. So I will be using the one available in June 1st. Okay. And next thing you do is to choose atmospheric correction criteria. And in this case, I will untick the second box, mask for dark pixels. This option is it's good for tropical water where seawater has higher transparency, but I'm not using this box here. I check this box because I want to mask land. I choose to execute atmospheric correction by the dark pixel method. I will be explaining a little bit details about how this dark pixel method are conducted in the second part of my presentation. So please check these two boxes, mask for land and execute atmospheric correction and dark pixel. And the next thing you do is to do a water depth correction. In the asset here, I have uploaded depth data in GeoTIFF format. So I will be using this depth data uploaded. And I will be masking area deeper than 10 meters. So I will just change this 25 to 10. So please do the same. Okay. Water column correction. By default, water column collection by depth invariant index method are given, but I will change this one to BRI, which is a bottom reflectance index method. Using this method uses the depth data you prepare, and in turbid, relatively turbid water, I know this method works better than depth invariant index method. Well, later you can change this and see the how the classification result changes by the water column correction. And the last thing you do is to give the Seagrass mapper the number of classes you want to use for classifiers to train satellite images. And in this particular case, I choose number 5. And I check this box supervised classification. And I will just use the one comes in the first place, random forest. And I'm not changing anything here. Well, all these details again are explained in the manuals, but here I just gave number 5 and check, and then check the supervised classification and check the random forest. So these are all the parameters that you need to specify. And then once it's all set, you hit run button. So now so yeah, you are supposed to get image like this, which is used in my presentation slide. This dark green is dense seagrass. Brighter green here is a mixture of sargassum and dense seagrass. And the yellow is sandy bottom, and purple here is mostly sandy, very few seagrass here. And these reds are sargassums. So is everyone getting like this kind of map?
Can you hear me there, Genki?
Yes, yes.
Yes. We have some discussion in the back of the room, so give us a couple of minutes. I'll check in
Sure.
with everybody here and then I'll let you know.
Okay, thank you very much. Wonderful.
No problem. Okay, Genki,
Mhm.
I'm switching you to microphone.
I just have a question regarding the okay. Yeah. Hi, I have a question regarding the classification methods that you can find in there. And as I can see, there is like random forest, and decision trees and so forth and so on. So what are those? Why have you chosen those? Why not, for example, maximum likelihood classification? Is there a reason behind it, or is it because they perform best?
Thank you for your question. This is a really good question, and we are actually working on adding maximum likelihood classification method in the list right now. And maxent in the list is not working right now, but so it's better not to check this one. And the details about all these methods are again explained in the manual. But in this case, I just use random forest method because it really matches with the field sampling result. But I also think maximum likelihood supervised classification works also good. This has proved in other softwares. So am I answering your question?
Yeah. I was just that was my question, why you've chosen those and not, but I guess these just perform better and good, but it doesn't mean that maximum likelihood wouldn't perform better bad. It's just I think
it works well. Yeah.
Okay.
From my experience.
Yeah.
And I think in the world of Google Earth Engine, they don't call this maximum likelihood in the same term. It's called Mahalanobis distance method or something. And
but is that not an unsupervised classification?
No, Mahalanobis it can be used for supervised classification.
Okay.
Yeah. And this update will be done by the end of this year. And yeah.
Okay. Cool. Thank you very much. Thank you.
Thank you.
If you uncheck supervised classification,
Yeah.
it will become unsupervised
Okay.
classification. The method will be week.
Okay.
You
Yeah.
choose a number of classes. And
Okay. Perfect. Thank you very much.
These files to
Sure.
Okay. Yeah. Thank you. Thanks a lot.
So you can just uncheck some of the box and hit run. You see classification result will change. And yeah, one thing I want you to test is maybe to switch to a depth invariant index method of water column correction. And yeah, and see different classification result. I mean, in this particular case, both water column correction method works fairly well. And yeah, and this section of the Seagrass mapper will give you overall accuracy of the image. And the tau coefficient, which is a reliability index for this overall accuracy. And this confusion matrix table. So I assume everyone is getting the same or the similar screen image. And so this is how fast Seagrass mapper can deliver you the classification image based on the field sampling data. And but what's taking more time for me was to prepare a nice set of field sampling data set, and also understanding the meaning of each training data. Here you see this layers section, and if you unclick this and check this classification, you will see that training data set used for this classifications. That is the top in the list. And if you click train WCC, this is this may be in a very dark color.
Are you guys here with Genki, right? Everybody in the front of the room? Yeah, okay, cool.
So see, yeah, it's this is, you see this dark rectangular shape polygon. This is used for water column correction, and I will be explaining a little bit details. And for atmospheric correction, I use these 3 boxes. Comes from very deep water, where there is no light reflection from seafloor. It's very deep.
Give me just a second.
Oh yeah, okay. So and yeah, this
Genki?
one.
Can you hear
Yes.
me there? We have another
Yeah.
question, so give me a second. I think it's easier if you come here.
Okay.
Okay, so this might not be relevant to Seagrass, but I'm just curious, do you think it is possible to use similar methods, what you do on Seagrass here, on a different ecosystem, such as maybe macroalgae habitats or coral reef habitats, or is this specifically just for seagrass habitats, designed for seagrass habitat mapping?
But it can be used for other applications like coral reefs, and it's all depends on the seagrass and not training data you have. Well, we just put the name because we are just focusing on seagrass mapping.
Yeah, because often in tropical seascapes, particularly where I work, you have coral reefs next to seagrass or seagrass next to coral reef. So it can be, well, it might be possible that there is misclassification between those, because coral reefs live in a symbiotic relationship with algae, so they have similar spectral reflectance, or may have similar spectral reflectance. So it would be maybe better to actually train the coral reef and the seagrass habitat just to get more accurate results in such an environment.
Yes. In my presentation, I had to differentiate class 1 and class 5 here to achieve better overall accuracy. And in Nanao Bay, and especially in this year 2015, there are large-scale sargassum like distributed throughout the bay, and it was like a mixing bed of seagrass and sargassum. So yeah,
Cool.
it all depends on the field data.
Yeah. Thanks.
Right now it's using that.
It's good thing.
But then we're asking also people to come here, so I thought it was that.
Okay. I guess we can move to the seagrass trainer, because a lot of people have tried out a few images and tried out the classification, and they're really excited about how about uploading their own data. So we'll go to that.
Okay. Okay, it's a timetable. Yeah, I think we are almost in line with a given timetable. was just checking the time. Okay. So it's time to prepare and upload a training dataset using Seagrass Trainer. Preparation of training dataset will take time. So in this exercise today, I prepared sample dataset for you. I mean, it's the same dataset that I used for the image classification on June 1st, 2015, and I made this training dataset available through the Google G Drive link. Okay. So first, please download the sample dataset from this link. If you haven't, yeah, this link information is available in the handout. So just copy and paste and download the whole folder. Okay. Just to give you a little more. Yeah, these are the contents under the sample now 1506, and we will be using all these data sets. And now I will be explaining what is AOI zip, what is area.zip, what is DTIF, and what are the others. Okay. So if you haven't, I will just copy the link and this link is different from the one this. Yeah, if you have problems downloading this dataset, please ask Trong on there. Okay, I will just continue. And then the next thing we will be doing is upload downloaded sample data along with Seagrass Trainer users manual page 19 to 24. Okay. Okay. So this is a recap from the first presentation. So roles of Seagrass Trainer and Seagrass Mapper. I will repeat the same thing. Seagrass Trainer here is used for registering training data so that Seagrass Mapper can read your training data as an asset in this window. And Seagrass Mapper can be used for mapping Seagrass using the power of Google Earth Engine. And one thing you need to know is that Seagrass Mapper asset is associated with one of the Google account. In this case, we use mapseagrass@gmail.com. So Seagrass Mapper is actually looking at, this is what's inside Google Earth Engine. And if you're familiar with Google Earth Engine, every Google Earth Engine account is associated with one of the Google account. And here we are using mapseagrass@gmail.com, and I'm just showing the asset associated with this Google Earth Engine account. So there are many assets of all users from the world. And the sample Nanao dataset manually created by me here. See, so this is the dataset we used for classification. And I'm saying this asset here is associated with mapseagrass@gmail.com account. Okay. Actually, there is a way to direct Seagrass mapper to one of your personal Google Earth Engine account asset information. In that case, you have to specify the full path of the asset. How to do this is again written in the Seagrass manual. So if you're advanced user of Google Earth Engine and you have asset information associated with your personal Google account, you can also read your personal asset information by giving the directory path. But in this exercise, we will be uploading the sample data set to this Google Earth Engine account using Seagrass Trainer. This is one important thing to know. Okay. There are many details about the difference between Seagrass Trainer and Seagrass Mappers. Like I said, Seagrass Mapper is not accessible in China, so we had to develop Seagrass Trainer. And Seagrass Trainer can handle more data formats in to be uploaded in training dataset, like Google KML, KMZ format. So if you have many field data organized in Google Earth Pro or any other Google tools, this Seagrass Trainer can do a conversion for you. But Seagrass Mapper cannot handle KML, KMZ directly. So this is one important thing to know. Other features, Seagrass Trainer is a non-interactive mapping tool, but like I said, Seagrass Mapper is an interactive mapping tool. Other than that, they are almost similar. Okay.
I have a quick question.
Yes.
So one question popped up that they want to do batch processing. Which one should they be using?
There are no functions, no such function yet. Like I wanted to have batch processing to be added for Seagrass Mapper, but that is in the future list of development.
Okay, thank you.
I mean, batch processing for multiple images, I guess, right?
Yes, for multiple images, for multiple satellite images.
Yeah. That is not available yet. Okay. Necessary data. Okay, so these are the necessary data for mapping Seagrass using Seagrass Mapper, Seagrass Trainer. Of course, you need satellite images, and this is in raster data format, and it's GeoTIFF usually, and this is must-have item. Can be prepared in Seagrass Trainer. Okay, you can also upload your satellite images associated with metadata. Some of you may be interested in using like commercial satellite imaging, which gives you a higher spatial resolution. So in that case, you need to upload your satellite images in the cloud asset. Like I said, in that case, you need metadata, and how to prepare this metadata is also written in the Seagrass Trainer manual. You need to create area of interest just to give Seagrass Mapper where to look at the satellite images. This is in the shape form, in a form of shape or KMZ, KML, CSV or GeoJSON data format. And You need training data sets for atmospheric correction. This is in the form of vector data type, and the file format can be same as area of interest. And this information is used for atmospheric, not just atmospheric correction, but used for land masking. And you need training data set for water column correction. Data type same as training atmospheric correction. And this is most important information to do the classification training data set for classification. And in case of Nanao, there are 5 classes given. So you need to create these data types in form of shape, KMZ, CSV, or GeoJSON. Okay. It's nice to have depth bathymetry data if you are doing precise water column correction. And in case of using bottom reflectance index method, you have to have this information. And I did not explain any like tidal correction, but if you are using tidal correction data, with the tidal level data, you also need depth bathymetry data. So if your case study site has a huge tidal level effect, you also has to have depth and bathymetry data to do a depth correction. Okay. So these are the data set you have to create in your region of interest, and this process is really time taking. So
There's
I'm
a
not.
question.
Yes.
Yeah, so the question is, if there's no water column correction, may I answer? You can skip water column correction. It's not always helpful. It's based on many assumptions. For example, that the water is horizontally homogeneous, or that it follows a certain attenuation. The BRI, the bottom reflectance index, was shown to work well in turbid water as well. But you don't have to. So you can just base on the surface reflectance with no correction. Oh yeah. So if there's no waters, then the water column correction. Yeah. Is that okay as an answer, Genki?
Yeah.
Okay.
Perfect.
Cool. Shall we move on? Okay. Yeah. Move on.
Okay. So these figures are showing the satellite images can be used for mapping Seagrass using Seagrass trainer and Seagrass mapper. The sensors below this green and blue line are what's available through Google Earth Engine data catalog for free of charge. These are publicly available data. So you can use Landsat 8 and Sentinel-2 with continuously observing the our ocean. And as I said, you can also upload commercial satellite images, such as GeoEye-1 WorldView, or WorldView 2, 3. And to do this, you have to read the manual and be sure to upload metadata associated with these satellite images. So I have done some testing using WorldView 2 in another field, and it works. It works very well if you are interested in detecting detailed features of the seagrass habitats. Okay, how to prepare area of interest? Well, in this case, I just draw this rectangular polygons like this, but it can be it can be any shape. I will be explaining another example of area of interest in the later part of my presentation here. Okay. Atmospheric correction, if you are using dark pixel method, you have to find the dark pixels. And dark pixels in the image are typically coming from very deep water. And in this particular bay, these three areas are like, these three areas represent the very deep water of the bay. The depth here is close to 20 meters, and it's very dark in this bay because it's a little bit turbid most of the time. So once the depth exceeds 10 meters, the water becomes very dark, and it reaches to like close to 20. There are no light reflection from the bottom. So you have to find this this kind of polygons if you are using dark pixel method for atmospheric correction. These two polygon shapes are for water column correction. And to draw this kind of polygons, you have to know the sea floor here is homogeneous. And there are no like vegetation on the ground. From the field sampling, we know these two areas are sandy bottom from shallow water to deep water. So you need to create a polygon shape from shallow to deep water like this to give information to Seagrass mapper the area used for water column correction. So the scientific meaning of this one is given by Lizenga, which I forgot. There is a paper you have to read to
1981.
1931, yeah. Okay.
1981, 1978 and 1981.
Yeah. So Tron knows better about this paper. So if you have a question, please ask him later. So you have to draw this kind of polygons from shallow to deep water where there is no seagrass habitat in the bottom. Like I said, it's nice to have bathymetry data if you are doing water column correction or tidal correction. And it has to be prepared in the format of GeoTIFF. And this exercise sample data set given to you. So create something like similar using our data set as an example, and then upload your bathymetry data in your region of interest. Okay. And one note here is bathymetry data needs to be recorded with positive values. Sometimes you have the minus most of the, but you have to convert it to a positive data. Okay. Otherwise, Seagrass mapper will not run. And you have to convert it before this, before run the classification. Defining areas for estimating the size of seagrass habitats. So, like I said at the beginning, the area of interest can be in the formal like this. I mean, this can be used for area of interest, but in this case, we are using this polygon shape to calculate the area extent of each class. And then this has to be saved with name area.zip. Yeah. Oh, one thing I forgot to explain, and this is important. Every training data set has to be have the same respective file name. For example, like in case of AOI, the file name has to be aoi.zip. In case of atmospheric correction, the name has to be atc.zip. For water column correction, it has to be water wcc.zip. So this is important. Otherwise, Seagrass mapper will not know which polygons corresponds to which type of like training data set. Okay. Okay. When you are uploading this area.zip, there is no menu in the Seagrass trainer right now. So just use the AOI from the list and upload area.zip as area AOI file. Training for seafloors. This is well, you will be defining the number of classes first, and in this case, there are five classes given. So in that case, train underbar C class, yes, class 3. So there is a typo here in this two. It has to be CLS3, CLS1, CLS2. Okay, so and again, this has to be in the form of .zip. Okay, so if you access to Seagrass Trainer, there is a dataset button here. And if you click the dataset button here, will take you to this window. And by clicking this upload button, this window, another window will pop up. And then you click upload button here and specify your local drive to find the type of training dataset that matches with this checkbox. In case of AOI, you just need to click this AOI button here and find any AOI.zip file and then upload. So after you upload to the Seagrass trainer, these are the images that you should be looking at. And once you uploaded all the training dataset, you will have to go back to home and then go to analysis tool and then hit the run button in the analysis tool. This button will send all these files to Seagrass mapper. Okay. And another thing you need to know is once you log in Seagrass trainer will give you asset name automatically. The current version of the Seagrass trainer, you cannot change the directory name. Asset name. Asset name are given by the time you log in Seagrass trainer. We are actually working on this this feature here to be able to modify the file name, the asset folder name for your convenience, because you don't want to remember all these numbers just given by the system. But at the moment, this is the only way to memorize which training dataset is which.
Shall we wrap up?
Sure. Okay. Yeah. Okay. So, like I said, this is how Seagrass mapper will look at your training datasets as an asset. So, in this case, REST test 4 is a username, and these letters here are given by the time of login. So we will be working on uploading Seagrass trainer and a training data set using Seagrass trainer now. Okay. So
since there's only 10 minutes left, would you like to let the participant try this at home? And if there's any questions immediately from the audience, or if you have, Genki, if you have any questions to the, say, the Seagrass manager around the world to see what features to update, maybe it's a good time to have that conversation.
okay. Okay, so you don't want me to like demonstrate quickly. I mean,
Oh, yeah, sure,
I
sure.
can. Yeah. Okay, so this is the interface of Seagrass trainer, and okay, so you just need to sign in with your ID and the password you created. So I just sign in with my ID, and then I click this dataset panel here, and I click this upload button, and I choose AOI, click to upload. This will take me to sample _ now 1506, and I choose AOI.zip and open it and send bucket. I'm not checking these two because I'm just using what's available in Google Earth Engine data catalog. And I will be uploading depth data here, send bucket. For training, atmospheric correction. And I quickly choose training dataset for water column correction. For training seafloor, you have to specify each class manually. I just uploaded class 1, class 2 now. Class 3. Okay, so once I uploaded all training dataset, I check the list, see, I'm not missing any. Okay, I was missing area.zip. So like I said, when you upload area.zip, you have to click this AOI at this version of Seagrass trainer. And then so once you're satisfied with all training dataset, you will need to go back to home, click analysis tool, and hit run. At this moment, Seagrass trainer is talking on the back end of Google Earth Engine. And there are trainings dataset being uploaded to Seagrass Mapper now, right now. And this process will take like several minutes. So you have to wait a little bit. It depends on the, it mostly depends on the performance of how busy the Google Earth Engine, and also how large usually this depth data. Depth data is here is very large. In this case, it's 42 megabytes or something. So it's all depends on the the area of your location and the size of the training data. Okay, so I just quickly show you how you upload training data set using Seagrass trainer. Okay. Yeah, Tron, I'm done.
Great. So, thank you very much, Genki, for the wonderful and timely presentation. Does we have any questions from the audience, or if not, then does Genki have any questions for the audience?
Yeah, it's more like a message. This Seagrass mapper was developed, well, the idea was developed 5 years ago, and we are working with Ministry of Environment of Japan and also United Nations Environment Program to further develop this application. But the development of the system is time-taking, and we want to share our knowledge in the process of development of the system in the further stage. And at the moment, Seagrass Mapper, all the code of Seagrass Mapper is not open source. But in the future version, we plan to involve many scientists in the development process. And I hope to work with all your people. And so your feedback is very, very appreciated. That's the only message I have.
Thank you. All right. So if there's no question, we will wrap up the session. And shall we take a photo together with Genki? Yeah. So just stay where you are. Thank you. So if you just stay where you are, the folks near the windows, if you could help close the curtain, it will help your face be brighter. And I'll bring Genki face up. And if Lorena can help take a photo from here. From here. Yeah. Did you see us, Genki?
Yeah.
Make you taller. Now you're as tall as me. So, yeah, shall we take a time?
Yeah, and I hope to go to the next ISBW.
Could you guys move maybe over there? So I can capture you. And yeah, also could you post this with Hunter? Thank you. Oh, this is great. Okay, another one. I'm gonna count this time. 1, 2, 3. Wonderful. Thank you so much.
Thank you so much.
Thank you very much. Yeah.
Thank you so much, Genki.
Oh, thank you, Tron. Oh, so how many more days left in the States?